The laws of physics were eternal. Humanity believed so. But deep in the interstellar darkness, something is racing toward us that breaks those laws. At that moment, astronomers recorded the universe is not what we thought it was. Hello, I'm Mike, the astronaut who will take you into sleep each night with cosmic hypotheses about the vast universe, based on real research, here at Deep Space Documentary. Today, we are going to explore an object that should not exist. A visitor from another star system, designated 3I/Atlas, is emitting a chemical signature so strange, so impossible, that it challenges everything we know about comets and the cosmos itself. Now, relax on your beloved bed, breathe gently, and get ready to board the spaceship with astronaut Mike for tonight's sleep voyage. But before we take off, if you enjoy my voice, please leave me a like and subscribe to the channel. And if you can, share your time and location in the comments below, so I can know where my fellow astronauts are joining me from around the world. Now, let's begin our cosmic journey. Deep in the darkness of interstellar space, racing toward our solar system at tens of thousands of kilometers per hour, astronomers have detected something that should be impossible. It is a wanderer, a ghost from a distant, unknown star, and it carries with it a message written in the language of light, a message that we are only now beginning to decipher, and one that may change our understanding of the universe forever. To understand why this visitor has astronomers speaking in hushed, diplomatic tones, we must first understand how fundamentally different it is from anything in our cosmic neighborhood. Its official designation is 3I/Atlas. The 3I marks it as only the third confirmed interstellar object ever detected passing through our solar system. It follows the enigmatic, cigar-shaped Oumuamua in 2017, which tumbled silently through our system, and the more conventional comet 2I/Borisov in 2019, which behaved exactly as a comet should. But 3I/Atlas is neither silent nor conventional. It occupies a middle ground that is somehow more puzzling than either extreme. The Atlas portion of its name honors the asteroid Terrestrial Impact Last Alert System, specifically the station at Rio Hurtado, Chile, where this cosmic traveler was first spotted on July 1, 2025. Imagine the scene: automated telescopes silently scanning the southern sky, their cameras capturing millions of pinpricks of light. Suddenly, algorithms flag an object moving with a velocity and trajectory that do not belong to our sun's gravitational family. Its path is what astronomers call a hyperbolic orbit, a cosmic highway leading from the interstellar void, bending once around our sun, and then heading back out into the galaxy. There are no return trips, no second chances for study. This is a one-time flyby. The mathematics are unambiguous. This object was born somewhere else, in a star system potentially hundreds or thousands of light-years away. From our perspective on Earth, this visitor poses no physical threat. Its closest approach to our planet will be approximately 270 million kilometers away, farther than the distance between Earth and the Sun. It will maintain a respectful cosmic distance, like a visitor admiring a garden from the street. The true mystery of 3I/Atlas began to unfold in the early morning hours of August 15, 2025. Astronomers at the European Southern Observatory's Very Large Telescope in Chile were analyzing the light signature of the object, a process known as spectroscopy. And there, dancing across their computer screens, were the unmistakable fingerprints of neutral nickel atoms, streaming from the comet as it was warmed by our sun. But it's what was missing that made seasoned scientists pause, mid-coffee: the iron. In our solar system, and in every comet we have ever studied, nickel and iron are cosmic twins. They are forged together in the hearts of dying stars. They travel together through space. And when a comet's frozen, surface heats up enough to release one. You almost always see both. Finding nickel without iron is like finding footprints in the snow from only one boot. The universe, it seems, does not separate these metallic siblings without a very unusual process. Or perhaps without intent. This raises a chilling question. We see pure, refined nickel on Earth all the time, but only as a product of industrial metallurgy. It is obtained through complex refining processes. Is it possible that what we are seeing is not a natural quirk of cosmic chemistry, but the product of space manufacturing? This is where the story of 3I/Atlas diverges from simple astronomy and enters a realm of profound speculation. Could this object be more than just a comet? Its predecessors offer a strange context. Oumuamua was inert, silent, and accelerated in a way we couldn't explain. Some still argue it was an alien solar sail. Borisov was a perfectly normal comet, a reassuring sign that nature, not technology, populates the void. But Atlas is active, like Borisov, yet its activity is chemically impossible, hinting at something more, something like Oumuamua. It's as if we are being shown two extremes, and now a cryptic middle ground. Let us consider a truly out-there hypothesis, the Sentinel theory. What if the galaxy is seeded with ancient, dormant probes, placed in stable orbits between stars millions of years ago? Their purpose, to observe, to listen, and to remain hidden. They would be designed to look like natural objects, asteroids or comets. But upon entering a star system with signs of technological life, like ours, the probe might awaken. The sun's heat could be the trigger, initiating a sequence. Perhaps the nickel emission isn't an accident. Perhaps it is a signal, a specific, narrow-band emission that is artificial, but masquerades as a natural element, designed to be detected by a civilization that has mastered spectroscopy. A sort of cosmic calling card that says, "We see you. We are here." It is a fantastic notion, but the data is equally fantastic. An object that produces nickel without iron, a nucleus hidden behind its own emissions, and a scientific community choosing its words with unusual care. The cosmos, after all, has begun whispering in nickel, and sometimes the quietest voices carry the most important messages. The mystery of 3I/Atlas deepens when we turn our gaze from what it emits to what it conceals. To truly grasp the strangeness of this visitor, we must first understand the cosmic blueprint for comets in our own solar system. They are the leftovers of creation, ancient snowballs formed in the frigid depths of space beyond the orbit of Neptune. Here, in the sun's faint light, temperatures were low enough for water, the most abundant volatile molecule in our protoplanetary disk, to freeze into ice. This boundary is known as the frost line, and it is the fundamental reason why our comets are, in essence, messengers of life-giving water. Their chemistry dominated by H2O, they are dirty snowballs, and their behavior as they approach the sun is a predictable consequence of this composition. The water ice sublimates, creating a vast, translucent coma of vapor and a tail that points away from the sun. This is the established model, confirmed by decades of observation. But 3I/Atlas appears to follow a different set of rules, as if it was written into existence by a different author of physics. The James Webb Space Telescope, our most powerful eye in the cosmos, turned its golden mirror towards this interstellar enigma. In the silent control rooms, data streamed back across millions of kilometers of space, translated into graphs and spectra. Scientists were looking for the familiar signature of water. Instead, what they found in the infrared light, specifically at the telltale wavelength around 4.3 micrometers, was an overwhelmingly strong signal of carbon dioxide. The discovery was so profound, so contrary to expectation, that the first reaction was to check the instruments, to run diagnostics, to question the calibration. But the signal was unwavering, confirmed by multiple observations. The data, once analyzed, painted a shocking picture. A carbon dioxide to water ratio of approximately 8:1. This is not just unusual, it is a fundamental inversion of cometary chemistry as we know it. To understand how extraordinary this is, imagine finding an iceberg in Earth's Arctic, composed not of frozen water, but of frozen air, with just a dusting of snow on top. It is a discovery that forces us to question the very definition of what a comet can be. This extreme carbon dioxide dominance creates what can only be described as a cosmic fog bank. Unlike water vapor, which is relatively transparent, the dense cloud of CO2 gas is optically thick, absorbing and scattering light in a way that forms an impenetrable shroud around the nucleus. The result is that even our most sophisticated instruments, from the Hubble Space Telescope in orbit to the giant observatories on Earth, are effectively blinded. We can see the fog, but we cannot see what is generating it. It is as if 3i/Atlas is wearing a cloak woven from its own emissions, revealing only what it chooses to show us, and hiding its true form behind a dense, chemically active veil. This chemical cloak makes it impossible to determine the most basic properties of the object within. We cannot measure its true size, only establish a rough upper limit. We cannot determine its shape. Is it a sphere, an elongated cylinder, or something more complex? We cannot measure its rotation or its albedo, the reflectivity of its surface. The Farsight Explorer mission's observations only deepen the enigma. Their imaging shows this extended carbon dioxide coma has no obvious jets or streamers. Most comets are lumpy, uneven bodies that heat unevenly, venting gas in powerful, localized jets that shoot out from active regions. These jets allow us to map their surfaces and understand their rotation. 3i/Atlas, however, appears to be outgassing with an almost perfect uniformity from its entire surface, creating a smooth, featureless glow. This uniformity is, in itself, highly suspect. It's more akin to a perfectly engineered sphere sublimating evenly in all directions than a chaotic, natural body. Of course, the scientific community has been working diligently to find a natural explanation. One leading hypothesis points to its birthplace. Perhaps 3i/Atlas formed in a stellar system vastly different from ours, maybe in the protoplanetary disk of a cool, dim M-dwarf star. These red dwarfs are the most common type of star in the galaxy, and their frost lines would be much closer and colder, potentially allowing for the formation of planetesimals naturally rich in carbon dioxide ice. Another theory focuses on its long, lonely journey. Over millions of years drifting through the interstellar medium, constant bombardment by high-energy cosmic rays could have created a uniform, insulating crust, a process known as space weathering. This devolatilized mantle might act like the lid of a thermos, suppressing the sublimation of the less volatile water ice trapped below, while allowing the more volatile CO2 to percolate through evenly across the entire surface. These are plausible, elegant explanations. They paint a picture of an object born in a truly alien environment, or one that has endured a long, torturous existence in the void. But what if the explanation is not natural at all? What if the cloak is not a coincidence of chemistry, but a product of engineering? This is where we must allow our scientific curiosity to venture into speculative territory. Consider the function of this shroud from a strategic perspective. It perfectly obscures the nucleus. It blinds our best technology. If you were designing an interstellar probe intended to pass through a potentially inhabited star system, and you wanted to observe without being fully observed yourself, a chemical cloak would be an ingenious form of stealth. It's not an energy shield or a metallic hull that would scream artificial. It is a shroud of gas that perfectly mimics a natural, albeit rare, cosmic process. The choice of carbon dioxide would be deliberate. It's one of the most common molecules in the universe. Perfect ingredient for camouflage. Imagine an ancient, advanced intelligence wanting to send a probe to our solar system. They would anticipate our technological level. They would know about our powerful telescopes, our mastery of spectroscopy. So they designed the probe not to be invisible but to be misidentified. The carbon dioxide outgassing isn't a byproduct. It is the primary function of the probe's outer layer, a deployable smokescreen. The uniform outgassing is achieved not by chance, but by a network of microscopic vents across the entire chassis, programmed to release the gas evenly to create a perfectly symmetrical coma, betraying no underlying geometry. The shroud might even serve a secondary purpose. As a potent greenhouse gas, it could help regulate the temperature of the internal mechanisms, protecting them from the cold of deep space and the heat of a close solar pass. This stealth screen hypothesis reframes every piece of data. The object's hidden core is no longer just a small celestial body. It could be a spacecraft, a data repository, or something far stranger. A biological ark with its cargo shielded by layers of frozen CO2. The shroud becomes a deliberate act of concealment, allowing the object to power up as it nears our sun, to gather data on our planet, our technology, our communications, all while presenting itself as nothing more than a scientific curiosity. It is the ultimate Trojan horse, a perfect disguise because it isn't a lie, but an exaggeration of a natural truth. It uses the laws of physics against us, turning a simple molecule into an impenetrable shield. We are left staring into a cosmic fog bank, able to analyze the fog itself in exquisite detail, but completely blind to the lighthouse, or the warship that might be hiding within it. The carbon dioxide shroud of 3I/Atlas isn't just obscuring our view of its nucleus. It may be obscuring our entire understanding of our place in the cosmos, hiding the chilling possibility that we are not just observing, but are, in fact, being observed. As the strange light from 3I/Atlas travels across the void to our telescopes, it splinters into two distinct realities. The first is the one presented to the public. A world of calm, measured reassurance and carefully chosen words. The second is a hidden world, one that exists in the digital ether of scientific collaboration, a realm of raw data, hushed excitement, and unsettling discoveries that are rewriting the rules of the cosmos in real time. To understand the full story of this interstellar visitor, we must learn to navigate both of these worlds, to read not only the official lines, but also the frantic whispers between them. When government space agencies like NASA and the European Space Agency speak about 3I/Atlas, their language carries the careful precision of a diplomatic communique. Their official statements read like a checklist designed to inform without alarming. Interstellar comet. Safe trajectory. No threat to our planet. They provide key dates. Perihelion around October 30th, 2025. Closest approach at a comfortable 1.8 astronomical units. The facts are presented with the emotional temperature of a weather report, technically accurate, reassuringly mundane. This measured tone is not accidental. It is a calculated strategy born from hard-won experience. The public and media reaction to Oumuamua's bizarre characteristics in 2017, its shape, its trajectory, its mysterious acceleration, spawned everything from serious scientific debate to wild speculation about alien spacecraft. With 3I/Atlas now presenting its own collection of anomalies, it is clear that these agencies have decided conservative communication is the better part of valor. Their press releases are exercises in de-escalation, providing just enough information to satisfy public curiosity, while carefully avoiding anything that might fuel the fires of speculation. The Minor Planet Center, the official clearinghouse for such discoveries, has been similarly restrained, dutifully recording the object's position to refine its trajectory, but offering no interpretive commentary. They are the cosmic equivalent of a court stenographer, recording what happened without editorial comment. Behind this cautious public face, however, lies a far more complex reality. The same agencies that speak in soothing tones are dedicating precious observing time from the world's most advanced and oversubscribed telescopes to this object. The James Webb Space Telescope, Hubble, the Very Large Telescope. These are not instruments you point at something mildly interesting. Every minute of their operation represents a colossal investment of time, money, and scientific capital. When space agencies coordinate observations across multiple billion-dollar facilities, they are making a silent statement about the object's profound scientific importance, even if they won't say so explicitly in a press release. The official line, in other words, may be less about what they know and more about what they are willing to say while the scientific process runs its course. But while the agencies practice diplomatic restraint, the scientific community operates in a different realm entirely, one where curiosity moves faster than institutional caution. This is the world of the preprint server, specifically a website called arxiv.org. It is the digital laboratory notebook for the entire planet, where scientists share their findings with colleagues, often within days of an observation, long before the slow process of formal peer review is complete. And in the case of 3I/Atlas, the preprints tell a far more intriguing story than any official statement. Here, in these technical papers, the European Southern Observatory teams working with the Very Large Telescope's UVES and X-shooter instruments laid out their astonishing findings. They documented the neutral nickel emission lines, and they confirmed the complete absence of iron. This wasn't a glitch. Multiple instruments confirmed the same anomalous result, moving the discovery from interesting if true to demanding explanation. Even more telling was the timing. Early spectra from July showed a relatively quiet, conventional comet, but the observations from mid-August, as the object drew closer to the Sun, showed the sudden emergence of not only the nickel lines, but also detectable cyanide, the CN molecule. This temporal correlation is a smoking gun. It suggests we are witnessing a complex chemical process unfolding in real time, an engine of unknown design being ignited by the increasing heat of our star. This wasn't a one-off observation. An independent confirmation of the cyanide onset was reported by Lowell Observatory, perfectly matching the VLT data. When multiple research groups using different telescopes report the same temporal evolution, it becomes incredibly difficult to dismiss. This is where we must ask a difficult question. Is the disconnect between the cautious official line and the revelatory lab notes merely standard scientific practice, or is it something more? Is it a form of managed disclosure? Imagine the dilemma facing these agencies. They have data suggesting an object entering our solar system possesses characteristics that are, at present, inexplicable by known natural phenomena. One of the quiet possibilities, however remote, is that it is not natural. What is the protocol for such a discovery? The truth is, there isn't one. The long-debated post-detection protocols remain largely theoretical. The fear, as outlined in historical studies like the Brookings Report, has always been that such a revelation could cause unpredictable social and political disruption. In such a scenario, the most responsible first step would be to control the flow of information, to release data slowly, and to frame it in the most conservative terms possible, buying time to study the object and understand what it is. Let's engage in a thought experiment. What if the nickel and the carbon dioxide are only the most obvious anomalies? What if there is other, more sensitive data being withheld? Faint structured radio emissions dismissed as interference. Brief unnatural glints of reflected light from the hidden nucleus. Subtle deviations in its trajectory that aren't quite explainable by outgassing alone. In this context, the institutional silence isn't a cover-up. It's a sign of the discovery's profound gravity. The preprint servers then take on a new role. They become a semi-sanctioned channel for information, allowing the scientific community to begin debating the data openly, slowly seeding the public consciousness with the idea that something strange is happening. It allows the most paradigm-shifting data to enter the conversation without an official agency having to stake its reputation on it. It is a way of preparing us, of gently acclimatizing humanity to a possibility that could change everything. We are left caught in the tension between two narratives: the official story, which is safe and simple, and the raw data, which whispers of the impossible. The truth, as always, likely lies somewhere in between, hidden in the careful warnings and the excited whispers from the frontiers of science. In the investigation of any great mystery, there often comes a moment when a single, anomalous clue is found. A fingerprint at a crime scene, a misplaced artifact in a tomb, a coded message in a string of random numbers. This single piece of evidence, if proven authentic, has the power to unravel the entire case. The detection of neutral nickel, stripped bare of its cosmic twin iron, in the spectrum of 3I/Atlas, represents just such a clue. It is a chemical fingerprint, precise and clear, left by an unknown visitor in our solar system. Now the task of the cosmic detective begins, to determine whether this fingerprint was left by a bizarre act of nature or by the hand of something far, far stranger. Science, in its rigor and integrity, must first exhaust every possible natural explanation, no matter how exotic. The universe is a place of immense variety, and our understanding of its chemistry is based on a limited sample from our own cosmic neighborhood. An object born in a completely different stellar nursery might be governed by chemical processes we have yet to witness. One such possibility for the nickel-iron separation involves a concept known as selective volatility. Imagine the nucleus of 3I/Atlas contains complex organic molecules, carbon-based compounds that might preferentially bind with iron atoms, creating heavy, stable materials. Nickel, in this scenario, would be left unbound, free to sublimate into a gas at much lower temperatures as the comet approaches our sun. The iron would remain locked away, frozen onto the nucleus. It's a plausible theory that hinges on a specific, and as yet unseen, internal composition. Another natural pathway might involve the object's immense journey through the void. For millions of years, its surface has been relentlessly bombarded by high-energy cosmic rays and interstellar radiation. This process, a form of space weathering, could chemically alter the surface materials in profound ways, creating a unique crust. This weathered layer might change how metals are bound and released, effectively creating a chemical filter that allows nickel to escape while trapping iron beneath. Perhaps the most compelling natural hypothesis involves the exotic world of carbonyl chemistry. The coma of 3I/Atlas is incredibly rich in carbon, manifested as carbon dioxide. In such an environment, under specific pressures and temperatures driven by solar heating, carbon monoxide could interact with metals on the nucleus to form transient compounds called metal carbonyls. Crucially, nickel carbonyl is a known compound that is far more volatile than most iron carbonyls. This could create a natural chemical engine where the sun's heat preferentially cooks off the nickel carbonyl into the coma, leaving the less volatile iron compounds behind. It is an elegant, if entirely speculative, mechanism that demonstrates how known physics could, under alien conditions, produce the impossible signature we observe. These natural pathways are scientifically sound hypotheses, and they represent the frontier of our understanding of astrochemistry. They ask us to imagine stellar systems with different compositions, comets with different histories, and chemical reactions playing out over millions of years. But they all share a certain complexity. They require a precise and fortunate alignment of unusual conditions. And then there is the other possibility, the one that is simpler, more direct, and infinitely more unsettling. The possibility that this is not natural at all. On Earth, pure nickel is not a mystery. We see it every day. It is the product of industrial processing. We create nickel-rich alloys and compounds with minimal iron content through smelting, electroplating, and advanced metallurgy. These materials are not curiosities. They are essential components of our highest technologies. In the super alloys of jet engine turbines, the reactors of nuclear submarines, and the specialized batteries of electric vehicles. The question, then, is unavoidable. Are we witnessing exotic chemistry, or are we witnessing industry? If we entertain this thought experiment, the nickel signature transforms from a scientific puzzle into a potential techno-signature, an alien fingerprint. What could it be? Perhaps it is the ablative shedding from an advanced heat shield, an alloy designed to vaporize layer by layer to protect the object within from the heat of its close solar pass. Or maybe it is waste, the exhaust from an onboard system, a compact fusion reactor or a decaying radioisotope power source, necessary to run the probe's systems, could be leaking trace amounts of its nickel-based components or catalysts. The heat generated by such a power source would be more than sufficient to vaporize these trace elements into the surrounding coma, creating the precise chemical signature we detect. This leads us to one of the most profound concepts in speculative science, the von Neumann probe. Proposed by the brilliant mathematician John von Neumann, it is the idea of a self-replicating interstellar spacecraft. Its mission is one of pure exploration and expansion. It would journey to a distant star system, seek out raw materials from asteroids and comets, and then, using its internal automated factories, build perfect copies of itself. Those copies would then launch towards new stars, continuing the cycle in an exponentially growing wave of exploration across the galaxy. A von Neumann probe would not be a sleek starship. It would be a functional, industrial machine, likely disguised to look like a natural object to avoid detection. Now, let us re-examine 3I/Atlas through this lens. The pieces of the puzzle begin to snap together with chilling coherence. The carbon dioxide cloak is the perfect stealth screen to hide the industrial complex within. The uniform outgassing is not the sublimation of a natural surface, but the steady, controlled thermal exhaust from its internal factories and power plants. And the nickel fingerprint? It is the industrial waste of a machine at work. Imagine the probe arriving in a previous star system. It identifies and consumes an iron-heavy asteroid, harvesting the elements it needs for replication: silicon, carbon, iron itself. What it doesn't need is the excess nickel. It refines this material and expels it as waste, perhaps coating its own hull or storing it in tanks to be vented later. What we are seeing is not part of the object's native composition, but the chemical residue of its last manufacturing cycle. We are not just seeing a comet, we are flying through the exhaust plume of an alien factory. While science must and should continue to rigorously test the natural hypotheses, the artificial explanation provides a disturbingly complete and self-consistent narrative. It accounts not just for the nickel, but for the CO2 cloak and the uniform outgassing. It connects all the anomalies into a single, logical framework. The natural theories, elegant as they are, each tend to explain only one piece of the puzzle at a time. The von Neumann probe hypothesis explains everything at once. And so we are left staring at this cosmic fingerprint, faced with two extraordinary possibilities. Either it is the signature of a natural world far stranger than we have ever imagined, or it is the undeniable trace of an alien machine, a silent, industrious visitor currently operating in our own solar system. The late great astronomer Carl Sagan famously stated a principle that has become the bedrock of all critical thinking. Extraordinary claims require extraordinary evidence. As we stand here in the early days of September 2025, with the interstellar visitor 3I/Atlas drawing ever closer to the Sun, humanity finds itself confronted with the ultimate test of this maxim. We have an object in our solar system exhibiting characteristics that defy easy explanation. The temptation, fueled by centuries of human hope and imagination, is to leap to the most extraordinary conclusion imaginable. But science is not about leaping. It is about building a bridge of evidence, piece by painstaking piece, that can safely carry the full weight of a conclusion. And for a claim as monumental as the discovery of an alien artifact, that bridge must be forged from the strongest and most irrefutable proof imaginable. This is why scientists hold back. Their caution is often misinterpreted as secrecy or a lack of imagination, but it is in fact the opposite. It is the product of a profound understanding of how easy it is to be fooled by the universe and by our own instruments. An astronomical observation is not a simple photograph. It is a cascade of photons collected by a mirror, focused onto a detector, and converted into digital signals. That signal is then contaminated with noise, from Earth's turbulent atmosphere, from the telescope's own electronic heat, from the faint background glow of the cosmos itself. The process of extracting a genuine signal from this sea of static is one of the most challenging tasks in science. It involves layers upon layers of calibration, error analysis, and statistical modeling. A tiny error in subtracting the sky's background light could create a false emission line. A miscalculation in a star's known brightness used for calibration could alter the apparent composition of a distant object. It is a process haunted by ghosts in the machine, and scientists spend their careers learning how to exorcise them. The astronomical community learned this lesson the hard way with our first interstellar visitor, Oumuamua. Its anomalous acceleration, a slight push away from the Sun that could not be explained by gravity, sparked an intense and public debate. Was it an alien solar sail, as proposed by some prominent scientists? Or was it a more exotic natural phenomenon, like an iceberg made of solid hydrogen? Or, as later proposed, solid nitrogen, venting gases in a way that was invisible to our telescopes? The debate was healthy and necessary, but it also showed how quickly an information vacuum can be filled with extraordinary theories. In the end, plausible natural explanations were developed that could account for the object's behavior without invoking alien technology. The experience left the scientific community with a collective sense of caution, a scar of humility. They are determined not to make the same mistake with 3I. Ensure that every natural possibility is exhausted before the alternative is even given serious weight. So, what would constitute the extraordinary evidence needed to meet this immense burden of proof? The unusual chemistry of 3I/Atlas is a tantalizing clue, but it is not enough. The proof would need to be something unambiguous, a signal or a characteristic that nature simply cannot produce. Scientists refer to these as technosignatures, and they have a well-defined list of what they are looking for. The clearest would be an engineered radio signal, not a random burst of static, but a narrow-band transmission, a signal confined to a tiny sliver of the radio spectrum, or a complex pulsed message containing mathematical patterns. Nature produces radio noise from pulsars to quasars, but it is almost always broadband and chaotic. A structured, intentional message would be the cosmic equivalent of a telephone ringing in an empty forest. Another powerful line of evidence would come from isotopic ratios. The elements in the universe come in different flavors or isotopes with varying numbers of neutrons in their atomic nuclei. The ratio of these isotopes is a fingerprint, a unique signature of the star system in which they were born. If we could get a detailed enough spectrum of 3I/Atlas, to measure its isotopes of, say, nickel or carbon, and found that the ratios were wildly different from those in our solar system and inconsistent with any known model of stellar nucleosynthesis. It would be a profound sign that the material had been artificially processed or manufactured. Then there is the signature of controlled propulsion. Oumuamua's acceleration was subtle and steady. A true techno-signature would be unmistakable. A sudden change in trajectory, a sharp braking maneuver as it approaches its target, or a course correction that defies the laws of orbital mechanics. It would be the equivalent of watching a piece of driftwood in the ocean suddenly turn 90 degrees and fire up an engine. Such a movement would be irrefutable evidence of controlled, intelligent guidance. Finally, there is the possibility of a direct observation of its structure. While the comet's cloak makes this impossible with optical telescopes, we could theoretically bounce a powerful radar signal off the nucleus. A natural object, like an asteroid or comet, would return a diffuse, fuzzy, and chaotic echo. But an artificial object might return a signal indicating geometric regularity, the sharp, glinting echo of a flat surface, the hard angle of a corner, or the strange, patterned return from an internal structure or cavity. It would be the sonar ping of a submarine in the deep ocean, revealing a shape where none should exist. To date, none of these definitive technosignatures have been reported for 3I/Atlas. But this is where our thought experiment must venture into the gray area, where the most compelling drama often resides. What if a potential signal has been detected, but it's ambiguous? Imagine, just for a moment, that as we enter September 2025, astronomers tracking the object with a radio telescope detect a single, powerful, non-repeating fast radio burst from its precise location in the sky. It has some of the hallmarks of the thousands of natural FRBs detected from across the universe, but some of its properties, its polarization perhaps, are just a little too clean, too structured. It could be a 1 in a billion coincidence, or it could be a communication. It is not extraordinary proof, but it is a deeply unsettling piece of data. Simultaneously, imagine that the teams tracking its trajectory notice a tiny, residual acceleration. It's almost, but not quite, explainable by the outgassing of its vast carbon dioxide coma. The models are pushed to their limits, but a small, persistent push remains unaccounted for. Again, it is not a smoking gun, but another fingerprint at the scene. This is the true scientist's dilemma. You are faced not with a single, clear piece of evidence, but with a pattern of multiple, independent anomalies that all lean in the same, extraordinary direction. You are in the gray zone, where the burden of proof has not been met, but the weight of suspicion is becoming immense. The encrypted emails between research teams would fly. The private debates would be frantic, because this is the moment when you realize that the burden of proof is not just about the data. It's about having the courage to confront the possibility that everything we thought we knew about our place in the universe is wrong. The data that streams back from 3I/Atlas is pure, simple, and unbiased. A string of numbers representing photons collected from the edge of the solar system. But the moment that data reaches Earth, it enters a vast and complex chamber of human interpretation. It becomes a signal that echoes through the machine of our global consciousness, bouncing off our hopes, our fears, our media, and our scientific institutions. Each echo returns a different, distorted version of the original truth. And as we sit here in the unfolding present of September 2025, trying to decipher the nature of this cosmic visitor, we find we must not only study the object itself, but also the chaotic and revealing echoes it creates within our own civilization. This chaotic information ecosystem has fractured into a spectrum of competing narratives. At one extreme, the tabloid and social media worlds have seized upon the mystery with predictable fervor. Their headlines, written for maximum engagement, vibrate with breathless excitement. Alien probe hiding in comet cloak, scientists baffled. NASA insider reveals secret message from interstellar craft. These outlets transform the careful, nuanced uncertainty of science into a simplistic drama of conspiracy and imminent revelation. Every unanswered question is presented as proof of a cover-up, and every cautious scientific statement is twisted into evidence that authorities are hiding a world-changing truth. In the middle of the spectrum sits responsible science journalism. Publications from Nature to Scientific American strive for a difficult balance, attempting to convey the genuine, profound scientific intrigue of 3I/Atlas without veering into speculation unsupported by evidence. Their articles explain why a carbon dioxide-rich coma matters, what the nickel without iron signature implies for astrochemistry, and why scientists speak so cautiously about preliminary findings. They are the translators, attempting to bridge the gap between the technical language of the laboratory and the curiosity of the public, a task made nearly impossible by the sheer strangeness of the object in question. And at the other extreme lies the official, institutional voice of the world's space agencies. As we have seen, their communications are exercises in meticulous restraint, sticking religiously to established facts, orbital parameters, safety assurances, and instrument capabilities. This institutional conservatism creates an information vacuum, a void of official interpretation which the more speculative outlets rush to fill. The problem is not that speculation occurs. Science advances through bold hypotheses, but that in the public mind, the line between established fact and imaginative speculation becomes dangerously blurred. To find a clearer signal, one must learn to read the primary sources, the scientific preprints themselves. Here, one learns to read between the lines, to understand the coded language of discovery. When a scientist writes that a phenomenon has a mechanism that is not yet fully understood, they are not simply saying, "We don't know." They are politely screaming that, "This breaks our current models." When they describe a finding as requiring unusual or unknown physics or chemistry, they are planting a flag, indicating that they may be on the verge of a truly novel discovery. These papers, filled with graphs and equations, are where the real story is being told. But it is a story written in a language that requires translation. As of this moment, several key questions remain pending, representing the front lines of this investigation. The robustness of the nickel signal is paramount. Will it remain consistent or even grow stronger as the object heats up on its approach to the Sun in the coming weeks? The true nature of the nucleus remains the greatest mystery, still perfectly hidden behind its carbon dioxide shroud. And the question of jets or a tail is critical. The object still appears eerily featureless. Is this a genuine characteristic, or is it simply the limit of what we can see from Earth? The upcoming observations from the Mars orbiters in early October represent our best and perhaps only chance to answer this, offering a much closer vantage point. But what if we are asking the wrong questions? What if the chaos, the confusion, and the scientific uncertainty are not just noise obscuring the signal, but are in fact the entire point? This leads us to a profound and deeply speculative hypothesis, that 3I/Atlas is an intentionally and intelligently designed test. Imagine a hyper-advanced civilization that wishes to make contact, but recognizes the immense risks of doing so. A direct, unambiguous appearance could shatter a younger society. So they design a probe that is ambiguously artificial. It is engineered to be scientifically baffling, to display characteristics that push right to the very edge of what is considered possible in nature. but to never provide a single definitive smoking gun of its own artifice. The purpose of such a probe would not be to study our geology or our biology. It would be to study us. Its mission is to be a psychological and sociological probe. The object itself is the stimulus. Our global reaction is the data it is collecting. How does this emerging technological species react to a profound cosmic mystery? Do they descend into panic and tribalism? Do they embrace conspiracy and reject the scientific process? Or do they react with reasoned inquiry, global collaboration, and a healthy balance of curiosity and skepticism? The probe's designers would watch our media, monitor our internet, and analyze our scientific debates. The entire cacophony of our global conversation becomes the subject of their study. This idea, all deliberate design choices intended to maintain a perfect state of plausible deniability. It is a test of our civilization's maturity. Perhaps it is even a standard galactic test, a form of the Great Filter. Civilizations that can successfully navigate this period of profound uncertainty, that can handle the mystery without destroying themselves, prove themselves ready for the next step. Those that fail are left to their own devices, deemed too volatile and immature for contact. From this perspective, the machine is not just the object in space. The machine is our entire global information network, and the echoes bouncing within it, from the tabloids to the preprints, are the very data the visitor came here to collect. The challenge presented by 3i/Atlas, then, may not be for our scientists alone, but for our entire species. The object is a mirror, and the reflection it shows us will be the ultimate measure of who we are. There is a unique and exquisite form of torture known only to the explorer. It is the discovery of a map to a lost world filled with indescribable wonders, only to realize that the map itself will crumble to dust moments before you can possibly reach it. This is the precise and agonizing feeling that has settled over the astronomical and aerospace communities in these tense weeks of September 2025. Floating through our solar system is arguably the most compelling, mysterious, and potentially important object humanity has ever detected. The temptation to see it up close, to send a probe, to touch it, is an almost primal urge, and yet we are utterly powerless to do so. We are confronted by the tantalizing prospect of a lifetime, a rendezvous with the visitor from another star, and that rendezvous has been denied. The denial is not one of will, but of physics. It is a sentence handed down by the cruel, unyielding tyranny of the rocket equation and orbital mechanics. 3i/Atlas was discovered on July 1st. Its closest approach to the Sun, its moment of maximum activity and scientific interest, will occur around October 30th. This is a warning window of barely 4 months. To understand the impossibility of this timeline, consider the fastest deep space mission in NASA's history, the New Horizons probe to Pluto. It required nearly a decade from its initial conception to its launch. The process of designing, building, testing, and launching a bespoke spacecraft is a monumental undertaking measured in years, not months. There is simply no rocket on Earth that can be prepared in time. Even if, by some miracle, we had a pre-built spacecraft sitting on a launch pad ready to go, the velocity requirements are staggering. Objects native to our solar system travel on predictable elliptical orbits. Intercepting them is a complex but manageable problem of timing. 3i/Atlas, however, is on a hyperbolic trajectory. It is not captured by our sun's gravity, it is merely being deflected by it. It entered our system with immense excess velocity, a speed it gained from its motion through the galaxy itself. To catch it, a spacecraft would need to achieve a change in velocity, what engineers call delta V, that is comparable to or even exceeds the most ambitious missions ever flown. And it would have to do so on a trajectory that is, for all intents and purposes, a head-on cosmic chase. Our chemical rockets, powerful as they are simply not capable of this feat on such short notice. The laws of physics have slammed the door in our face. But humanity is not sitting idle. Where a bespoke mission is impossible, ingenuity prevails. The astronomical community has orchestrated the next best thing, an opportunistic observation campaign using our existing robotic assets. And by a remarkable stroke, 30 million kilometers of Mars. From the vantage point of the red planet, the interstellar visitor will appear significantly brighter and larger than it does from Earth. For this brief period, Mars will become our forward operating base, a deep space observatory. The European Space Agency has already begun redirecting its fleet of Mars orbiters, spacecraft like the ExoMars Trace Gas Orbiter and Mars Express, turning their powerful cameras and spectrometers away from the Martian surface and out into the blackness of space. For a few precious hours, their mission will not be to study Mars, but to spy on its interstellar visitor, potentially capturing details, faint jets, coma structures, perhaps even a hint of the nucleus itself, that are completely invisible from our more distant home world. This is the practical response. But it is in the space between the practical and the impossible that the most profound speculative questions arise. We must ask, why is a rendezvous denied? Is this a simple accident of timing and technology, or could it be a deliberate feature of this object's encounter? Let us assume for a moment that 3I/Atlas is an artificial probe. Its designers would be an intelligence of unimaginable advancement. They would understand the laws of physics as well as or better than we do. They would have the ability to calculate our technological capabilities with perfect precision, our detection thresholds, our rocket equations, our institutional reaction times. With this knowledge, they could plot a trajectory that was perfectly engineered to be a high-speed flyby, a path designed to enter our detection range with just enough time for us to find it, to become fascinated by it, and to study it intensely from a distance, but with absolutely no time for us to ever physically intercept it. This would be a form of cosmic non-interference protocol, a no-touch policy. It is the same principle a wildlife biologist follows, observing a reclusive and potentially dangerous animal from the safety of a blind. The goal is to gather data without disturbing the subject, without contaminating the experiment. In this scenario, we are the subject. The probe's mission is to observe us, and its trajectory is a guarantee that we cannot turn the tables and observe it too closely. It is a masterclass in cosmic reconnaissance, allowing the probe to gather its data while ensuring its own safety and technological secrecy. This hypothesis imbues the upcoming Mars flyby with an almost unbearable tension. Our robotic emissaries are about to get our closest look. What will they see? We can only speculate, but the possibilities are chilling. Imagine the thermal cameras on a Mars orbiter detect a persistent, localized hotspot on the hidden nucleus, a point of heat that cannot be explained by solar radiation. It would be the faint, telltale glow of an internal power source, glint of reflected sunlight, the unmistakable signature of a smooth, manufactured metallic surface. Not the dull, uneven texture of a dusty comet, or, perhaps most disturbingly, imagine its spectrometer sees the chemical composition of the outgassing subtly shift as it passes Mars. as if the probe were making a minute course correction or deploying a smaller secondary device into our solar system. Any such data point would be a profound piece of the puzzle. For now, we can only wait. Our inability to physically reach 3I/Atlas, a source of immense scientific frustration, may itself be the most compelling piece of evidence we have. The object's entire encounter seems designed to create mystery, to spark debate, and to test our abilities, but to deny us ultimate proof. We have been given a front-row seat to the most extraordinary event in human history, but we have been firmly forbidden from ever going backstage. Time moves differently for interstellar visitors. While we on Earth mark our lives by the rising of the sun and the turning of the seasons, 3I/Atlas follows a cosmic calendar, one written in the immutable language of gravity and orbital mechanics. Its schedule was set in motion thousands of years ago in a distant star system, and for a few brief, precious months, its timeline has intersected with our own. But that window is now closing. We are entering the final act of this extraordinary cosmic drama, and the curtain is beginning to fall. Understanding this final calendar is essential to appreciating what we've learned, and what mysteries may be about to disappear forever into the void. The countdown is already underway. As we move through these final weeks of September, we are in our last period of clear, unobstructed observation from Earth-based telescopes. Each night, every major observatory on the planet that can see it is capturing as much light as possible, knowing that soon the object will slip into the sun's glare. The most pivotal date on this calendar is fast approaching, October 3rd, the day of the Mars flyby. On that day, our robotic proxies will give us our closest and perhaps most revealing look. The data from that encounter will take time to be relayed and analyzed, but it represents a crucial climax in our investigation. After that, the timeline accelerates towards the main event. Around October 30th, 3I/Atlas will reach perihelion, its point of closest approach to the Sun. At a distance of roughly 203 million kilometers, it will be bathed in the most intense solar radiation of its entire journey through our system. This is its moment of trial by fire. If the object has more secrets to reveal, this is when they will likely be forced out. Any remaining volatile ices will sublimate, any internal processes will be at maximum activity, and its chemical cloak will be at its most energetic. If a final, revealing message is to be sent, this would be the time. And then, with the most frustrating timing imaginable, at its moment of peak drama, it will vanish. Through most of November, 3I/Atlas will be in solar conjunction. From our perspective on Earth, it will be lost behind the overwhelming brightness of our own star. This observational blackout is one of the cruelest twists in this story. Just as the object is at its most active, we will be completely blind. We will have one last chance. In early December 2025, it will emerge from the sun's glare, a ghost reappearing in our morning sky. But this will be a different object. It will be receding, cooling, and fading with each passing day. This post-perihelion observation period will be a frantic epilogue, a final opportunity for our instruments to say their goodbyes and capture the last few photons before it becomes too faint to see. By mid-2026, it will have disappeared beyond the reach of even our most powerful telescopes. Its journey through our solar system complete as it begins. Its million-year voyage back into the interstellar night. As it prepares to depart, we are left with the two grand narratives that have defined its passage. The first is that 3I/Atlas is a natural wonder, an ambassador from a truly alien stellar environment. In this story, its strange chemistry is not a sign of technology, but a priceless clue to the diversity of planetary formation across the galaxy. It teaches us that comets can be born in carbon-rich, water-poor systems, a possibility that will reshape our models of how solar systems are built. The hidden nucleus and uniform outgassing speak of a long and brutal journey through interstellar space, its surface weathered and processed by eons of cosmic radiation. It arrived as a mystery, but it will leave as a Rosetta Stone, allowing us to translate the language of light into a new understanding of the cosmos. The second narrative is the one that whispers to us in the quiet hours of the night. It is the story in which 3I/Atlas is an artifact, a probe, a piece of alien technology. In this version, every anomaly is a feature, not a bug. Its impossible chemistry is an industrial byproduct. Its chemical cloak is an intentional act of stealth. Its denied rendezvous is a deliberate, high-speed flyby, a no-touch policy from an intelligence that wishes to observe without being observed. It is a test, a riddle sent to a developing civilization to gauge its maturity. It arrived as a scientific curiosity, but it will depart as a profound and unsettling challenge to our place in the universe. Both stories remain consistent with the evidence we have, and as we approach the climax at perihelion, we must consider a final, speculative possibility. What if the object's primary purpose is still to come? What if the intense bath of solar energy at perihelion is not just an obstacle to be endured, but the trigger it has been waiting for? Perhaps, in those final hours before it enters solar conjunction, its mission will change from passive observation to active transmission. A single, powerful, and unambiguously artificial radio signal. Or, perhaps more elegantly, the intense heat will finally overwhelm its cloaking system, causing the carbon dioxide shroud to burn away, revealing, for just a few fleeting moments, the true geometric, manufactured shape of the object within. But the most likely outcome is that 3I/Atlas will leave as it arrived, in silence and in mystery. It will bequeath to us not an answer, but a permanent state of uncertainty. Its legacy will be to force humanity to create a new category for cosmic phenomena, a class of objects that exist on the boundary between the natural and the potentially artificial. Its passage will undoubtedly ignite a new sense of urgency, a new space race, not to conquer other worlds, but to develop the rapid response intercept technologies, like those envisioned in Project Lyra. The true identity of 3I/Atlas may be less important than the questions it forced us to ask, and the mirror it held up to our civilization. It arrived as a ship passing in the galactic night, a brief flash of impossible light that served only to illuminate the vastness of our own ignorance. It will depart, leaving behind only the data we've collected, and a universe that suddenly feels much larger and much less empty than it did before. For generations to come, astronomers and dreamers will look up towards the heavens and wonder about the visitor that came and went. A cosmic riddle that will hang forever in the consciousness of a species just beginning to open its eyes to the universe.